Instant noodles are one of the most efficient foods ever engineered, designed to deliver a hot, filling meal in just minutes using nothing more than boiling water. Yet behind every lightweight block or sealed cup is a highly optimized industrial system that combines food chemistry, mechanical precision, thermal processing, dehydration science, and ultra-high-speed automation. What seems like a simple convenience product is actually the result of decades of refinement, aimed at speed, consistency, shelf stability, and flavor delivery at massive global scale. Billions of servings are consumed every year, and every single one must hydrate properly, taste consistent, and remain safe for months on store shelves. And today on the How Factory, we're stepping inside modern noodle plants to see exactly how instant noodles are made. From raw flour and water to sealed cups ready in minutes. The origin of instant noodles dates back to the mid-20th century, when rapid urbanization and food shortages created demand for affordable, long-lasting meals. Traditional fresh noodles required refrigeration and cooking time, making them less practical for busy city life. The breakthrough came when manufacturers discovered that pre-cooking noodles and then removing moisture in a controlled way created a porous internal structure. These microscopic pores allow hot water to penetrate quickly during preparation, rehydrating the noodle almost instantly. That discovery transformed noodles from a regional staple into one of the most widely distributed food products in history. The process begins with wheat flour, the structural foundation of the noodle. Flour arrives at the factory in bulk silos or tanker deliveries and is stored in temperature-controlled conditions to maintain quality. Before entering production, it passes through sieving systems that remove clumps and foreign particles. Consistency at this stage is essential because protein content affects gluten formation, which directly influences noodle texture. Water is filtered and temperature adjusted before mixing. The key chemical ingredient added during mixing is an alkaline solution, typically containing sodium or potassium carbonate. This alkaline component raises the pH of the dough, strengthening gluten bonds and giving the noodle its distinct yellow color and elastic bite. Salt is also added, improving flavor and tightening the protein network. All ingredients are measured automatically using computer-controlled systems to ensure precise ratios in every batch. Inside large industrial mixers, the flour and liquids combine. Unlike bread dough, noodle dough contains less water and forms a crumbly texture rather than a smooth, elastic mass. The goal is even hydration without overdeveloping gluten. Mixing time, speed, and moisture content are carefully controlled. Too much water results in sticky sheets that tear during rolling. Too little creates brittle strands that break during shaping. Once mixed, the dough moves to a rolling line. Heavy stainless steel rollers compress the crumbly dough into thin sheets. The sheet passes through multiple rollers in sequence, each reducing thickness gradually. Between passes, the sheet may be folded to improve structure and alignment. This rolling stage aligns gluten strands in one direction, creating strength and elasticity. Thickness control is critical. Modern plants regulate it to within fractions of a millimeter. The thin dough sheet then enters a slitting machine, where precision blades cut it into hundreds of continuous strands. Immediately after cutting, the strands are gently waved into a curly pattern using oscillating conveyors. The familiar curl of instant noodles is functional, not decorative. The waves increase surface area, making rehydration faster and helping broth cling evenly during preparation. The raw-shaped noodles are not yet edible. They move into steam tunnels where high-temperature steam partially cooks them. This steaming stage gelatinizes starch and locks the noodle structure into place. Conveyor speed, steam pressure, and exposure time are tightly controlled. Overcooking weakens structure. Undercooking affects rehydration performance. Within minutes, the noodles exit the steam chamber with their structure stabilized. After steaming, the continuous noodle sheet is cut into individual portions. Automated cutters divide the strands into blocks of uniform weight. For packet noodles, the portions are folded into rectangular bricks. For cup noodles, the portions are shaped and dropped directly into cups. Weight sensors ensure each serving meets strict specifications, as even slight differences can affect cooking consistency and packaging efficiency. The next stage is what makes instant noodles truly instant: dehydration. There are two primary methods used in modern factories. The most traditional is flash frying. Noodle blocks are submerged in hot oil at temperatures typically above 140 degrees Celsius. The intense heat rapidly evaporates water inside the noodles, creating thousands of microscopic pores. This porous structure is what allows boiling water to penetrate and rehydrate the noodles in just a few minutes. Flash frying also adds flavor and contributes to the characteristic aroma many consumers associate with instant noodles. The alternative method is hot air drying. Instead of oil, noodles travel through long drying tunnels where heated air removes moisture gradually. This method reduces fat content and is often used for health-focused products. However, air drying requires more precise control to achieve the same internal pore structure. Both methods aim to reduce moisture to very low levels, preventing microbial growth and extending shelf life to months or even years. After drying, the noodles are cooled to prevent condensation. At this stage, they are lightweight, stable, and structurally complete. Meanwhile, seasoning production operates in parallel. Seasoning packets are a complex blend of ingredients designed to dissolve quickly in hot water. Powdered seasonings may include salt, sugar, flavor enhancers such as monosodium glutamate, spices, dehydrated vegetables, meat extracts, and powdered oils. Each ingredient is weighed automatically and blended in large mixers to ensure even distribution. Flavor consistency is critical because the seasoning defines the brand's identity. Liquid seasonings such as soy sauce or chili oil are prepared separately. They are cooked, filtered, and portioned into small sachets using automated filling machines. Dehydrated toppings, including vegetables, herbs, and textured proteins, are produced using freeze drying or hot air drying. These toppings must rehydrate quickly without losing shape or texture. Packaging is one of the fastest operations in the plant. For packet noodles, dried blocks move into horizontal wrapping machines. Printed film wraps around each block, seasoning packets are inserted, and the package is heat-sealed in milliseconds. For cup noodles, the process is more layered. Cups arrive pre-formed and are cleaned with filtered air. Noodles are dropped in, followed by toppings and seasoning. Foil lids are applied and sealed under controlled conditions to keep moisture out. High-speed vision systems inspect every unit. Cameras verify fill levels, seasoning inclusion, seal integrity, and date codes. Any defective package is automatically rejected without slowing production. Random samples are pulled for quality checks, including weight measurement and cooking performance tests. Quality control extends beyond packaging. In laboratory kitchens, technicians prepare samples from each production run. Noodles must rehydrate within the target time, maintain elasticity, and distribute seasoning evenly. Broth clarity, aroma, and taste are evaluated against established standards. Shelf life studies simulate months of storage to ensure flavor and texture remain stable. Finished products are boxed and palletized by robotic systems. Because instant noodles are compact and shelf-stable, they are ideal for global distribution. Containers of noodles are shipped across continents, stocked in supermarkets, convenience stores, and emergency supply warehouses. Modern factories often operate 24 hours a day to meet global demand. Production lines can output tens of thousands of units per hour. Automation minimizes human contact, improving hygiene and speed. Clean-in-place systems sanitize mixers, steamers, and fryers between runs to prevent contamination or flavor carryover. Sustainability is increasingly important in noodle production. Factories recycle frying oil, recover heat from steam systems, and optimize water use. Packaging materials are being redesigned to reduce plastic content. Some facilities use renewable energy or convert production waste into animal feed or bioenergy. What makes instant noodle manufacturing remarkable is how efficiency, chemistry, and engineering combine to create convenience. Every element, from alkaline dough formulation to pore formation during frying, exists for a specific functional purpose. The result is a product that can be stored for months, shipped worldwide, and transformed into a hot meal in just minutes. From flour silos and mixing systems to rolling lines, steam tunnels, flash fryers, seasoning blenders, and ultra-fast packaging machines, instant noodles are a triumph of industrial food engineering built for modern life. And that is how instant noodles are mixed, rolled, steamed, dried, seasoned, packaged, and shipped, transforming simple wheat flour into one of the fastest and most widely consumed meals on Earth. Thanks for watching The How Factory.